Hello guys, welcome to my channel. In this video, I'll teach you how you can measure the distance using Arduino UNO and a ultrasonic sensor HC-SR04. Okay. So now, first I want to say what component we need for this project. So you can see here, for this project, you just need two components. One is Arduino, so I am using Arduino UNO version here, and another is ultrasonic sensor for measure the distance. So here I am using HC-SR04 ultrasonic sensor. So before move to wiring, I want to say about the ultrasonic sensor. Okay, so you can see here in the ultrasonic sensor 4 pin here. So the first pin here, this is the VCC or positive. This means this pin is for power supply, 5 volt power supply for the ultrasonic sensor. The next pin is trigger. This is for trigger. Okay, so this is a output pin, and the next is echo pin. Okay, so this echo pin is for receiving the signal. Okay, and this is a input pin. So TRIG pin is output and echo pin is input here, and the last pin is ground. So the 4 pin, which is this, so the 4 pin is VCC, trigger, echo, ground. Okay, so now we move to wiring. So we know the VCC here, this is a 5 volt module. So the VCC pin will connect the 5 volt supply of the Arduino UNO. Okay, so you can see here the 5 volt pin here. So I am taking a jumper wire and connecting with the VCC pin. Okay, this is a positive supply and the color will be red. Okay, and the next we will connect the ground pin. Okay, we know the ground or negative, so we'll connect it with this pin. This is a Arduino ground pin. You can see here after the 13 pin. So this is a ground pin. So we'll connect the ground of the Arduino with the ground of the ultrasonic sensor. You can see, and this will be black. So the positive and negative is connected. Okay. Now the remaining is TRIG pin and echo pin. So for these two pin, we'll use microcontroller digital pin. Okay. So before we connect, we want to see you the code for this project, and after that we will connect the TRIG pin and echo pin with the Arduino UNO. So you can see here, this is the very basic code for this project to measure the distance by using the ultrasonic sensor. So at the beginning of this code, we just write the pin number for echo pin and TRIG pin. So now in the void setup session, we'll write our setup code here. So for this project, our setup code is, first we start the serial begin with the baud rate of 9600, and after that we'll write pin mode for telling the microcontroller about our pins, which pin we are using and what type of pin it is. So this is our setup code. So next is while loop. So in this part, we'll write our main code here. Okay, so digital write TRIG pin low. So digital write function is used for low trigger pin. After that, digital write function is used for high the trigger pin, and a delay is used. You can see here. So a delay is used after high the trigger pin. 15 microsecond delay is used, and after that again we used digital write function, which is output function, and we write TRIG pin low. So we up the TRIG pin. So now in the next line, you can see I am using a variable with name duration for to store the duration. Okay. After that, what I am doing, we will convert the duration into the distance. So I am taking a variable distance. Distance is equal to duration into 0.034 divided by 2. So this line, what will do? This line will convert the duration into distance, and the distance will be in centimeter. Okay, and after that we are using a delay. Okay, so I'll provide you the code in the description, so you can copy it from here. So now we'll connect the trigger pin and echo pin with the Arduino UNO. So first of all, we see the pin number here. The trigger pin is pin number 11, echo pin is pin number 10. So the trigger pin is here. Trigger pin is pin number 11, and echo pin is with number 10. Okay, so the circuit is completed. Now we'll run our code and see what happened. So now I'm click on start simulation and opening serial monitor. You can see here the distance is displaying here. So 112 centimeter, 112 centimeter distance right now. If we click on this module and move this object, so you can see here the distance is increased. If we move this close, so you can see the distance is 80 centimeter. So the distance is measured correctly. So the code and circuit is working properly. Okay. So thank you so much for watching this video. Please like and subscribe. Thank you so much.